Welcome back to your MATLAB mentor, where MATLAB turns math into motion. Let's code smarter, not harder. Opening up a new episode, today we'll continue our talking about another several topics, so please make sure that you have been watching all the previous episodes as they are all depend on each other. Today, our topics will be a little bit mathematics based, but it's also very important for application wise. So most of our work is just based now like on MATLAB documentation or MATLAB help, and it's all inspired from there. The reason for that because at any exams or any labs, like whether you're still in school or outside, it's always like reference. It's always reference over there, and you can access to it at any time you want. So because of this reason, we wanna like reflect back on MATLAB documentation because it will be always there for you if you need any help. So without any more introduction, let's begin. So today we're gonna talk about two important topics, which they are Polyfit and Polyval. So both of them, I would like to call them brothers for life. And why I call them that? Because both of them always depend on each other. Like Polyval always comes after Polyfit, and if there is Polyval exist, Polyfit has to exist as well. So both depend on each other. So in another words, so polyfit it just does mean polynomial curve and fitting. So it perform like centering and scaling like for improving numerical properties of both the polynomial and fitting algorithm. As I said, it's just like little bit mathematical based, but it's very important to know for like application or like for different sectors if you do work in. Okay, so let's begin. So let's create an x variable base. So 0 to pi and 10. I think you guys now like expert with this. We explained this several times. Starting with 0, okay, the 2 pi will be the end with 10 evenly spaced in between. So at the start with 0 and in 2 pi, between 0 and 2 pi there is 10 evenly spaced like on the graph or in the figure. So we're gonna see like 10 intervals between 0 and 2 pi. This is what it means. So now this is my variable x. If I press run, I have the variable now in the workspace. So let's make y equal sine x. Now I have also y. Both are the same size, and we said because like when I do plot, it must be the same size. And now let's try the polyfit. So polyfit does expect x and y and n. And n is just the degree of polynomial fit. Okay, so I already create x, right? So I would like x and then y, and for n is 7. So understand what x and y, but 7 it's just like degree of fitting, which like you should expect 8 values as a sequence because it's like 7th degree polynomial, and usually like polynomial it's always n plus 1. So 7 I'm gonna expect like 8 values because it's n plus 1. 8 I'm gonna expect 9 values and so on. So if I press run right now, 1 2 3 4 5 6 7 8. So this is 7 degree of polynomial fitting. Okay, so far so good. So let's now time for the brother of polyfit. I said they are brothers for life. So brothers has similar things, right? So let's create now x1 and this for the brother, which is polyval. Okay, let's make it 0 to pi and that's it. So from 0 to 2 pi, I leave it as a default. Oops, line space. So if I didn't specify any digit here, it means now it's 100 evenly spaced. So we're gonna start with 0, and at 2 pi, between 0 and 2 pi, there are gonna be 100 intervals between them. Okay, so this is my x1. And now let's start with Polyval. So usually the difference between axes between x and x1 is not like that big, because we are trying to measure the fitting for the most part between like Polyfit and Polyval. That's why like both are 0 to 2 pi, but the difference just will be in intervals. Like the x has 10 intervals, but x1 has 100 intervals. Okay. Now for Polyval, will be P, which is the brother, the Polyfit, and then x1. Now I used Polyfit and Polyval, so we can run. Now I have those values, but in order for us really to see it, we have to make a plot and make a figure in order to see the difference between them. So right now the B is just polynomial coefficient, and x1 is the axis of Polyval. So let's create a figure to see like in a better representation. So figure 1. And this is always the thing too. So even if it's very mathematical functions, but we are creating a figure along the way, we are creating axes along the way. So you kind like always reinforce what you learned before, even if you are applying a very mathematical or like a new function like that you might use in a very specific technical stuff or generalized, but along the way you are applying what you have learned before. So we're gonna start with x and y, and this CEO because this marker symbols this circle. So the first plot will be representing by circles, and then hold on, and then also plot. So hold on to make the two plots in just one figure. This time x1 with y1, basically this for Polyval, and then hold off. So this plot is for the Polyfit, but this one will be like how we can like how the Polyfit did perfect fitting when we did plot the Polyval. So we're gonna see the relation between each other. So right now if we press run, so here we go. So we have the Polyfit in the shape of circles, and for the Polyval we have like the polynomial curve, and this is the places that we can see Polyfit in the places, and the x-axis as we mentioned from 0 to 2 pi. Okay, and the spaces it's 7 degree of polynomial, which is 0 1 2 3 4 5 6 7 8, and this is the end one. So it's always you can like specify the degree of polynomial over here, and this is the relationship between Polyfit and Polyval. That's why like they are always brothers. Okay, let's try. So I know it's is not hard, but of course it needs like several practice along the way. Let's try something else. Let's try now Polyfit for specific group. So this won't be that different, but it's very good for practicing reinforcement what you learned. Okay, so now x equal line space 0, 1. But right now I want to choose to start at 0, end at 1, but there is 5 evenly spaced in between. Let's clear all here in order not to have like overwriting a lot of variables. I did that because there was x here and same variable x here, so I don't want to confuse you guys with x3 or something. But now if I don't have anything in a workspace, I will run section by section, because this one section, this another section. So when I run this, there is no error or overwriting error will happen. Okay, so as I said, this just 5 evenly spaced between 0 and 1. Y equal, so 1 dot 1 plus x. Okay, so what is this? This just equivalent to 1 plus x power negative 1. So 1 division, or 1 over 1 plus x, is the same thing as 1 plus x power negative 1. So okay, so now representing the polyfit, same sequence. I want you guys to be familiar with this sequence, because like it can be repeated several times. So the P is polyfit, same thing, my axis x and y. Now you guys understand 4th degree of polynomial fit, so it's 4th degree. Now time for his brother Polyval. So we're gonna set his own axis, which is x1 will be 0 and 2. Also line space. And here the default will be 100 evenly spaced. And as I said, like the axis is kind matches like 0 and 1, 0 and 2, because we are trying to see the variation between polyfit and polyval. And now we're gonna create y1, and this will be for a reason. So same equation but different axes. This y, it was x, but y1 gonna be x1 for the polyval. And now let's create the brother, which is f1 would be polyval. Always the b polynomial fit over here, and then the axis of polyval, which is x1. Sweet. So if we press run, no errors, we have all the variables that we did specify. But as I said, in order to see the relationship between polyfit and polyval, you need a figure. So let's now create the figure. Let's name this figure to so first plot will be x and y, the original one, and I want to be the same sequence. I want to represent the polyfit with circles. So here our target to see where are the places the polynomial was actually fitted in the polyval or in the polynomial line. And also like hold on it, just like as I said before, putting several plots on one figure. So right now let's plot the polyval. So x1 with y1. Okay, this will represent the polynomial line, which is, those are the axes of the polyval, right? Now I want to represent polyval itself. So another plot will be x1, f1, f1, which is a polyval, and then let's make this red and line style to be two dot or two like underscore. So this plot is to see whether or not there was any diversion from actual plot. And let's create a legend in order not like to get lost because there is several variables. So legend, the first one is y, second one y1, third one y f1. So f1 is the polyval, y is polynomial fit, and then maybe location best. And as I mentioned before, location best is just I'm telling MATLAB choose the best locations that you can see. Okay, moment of truth. Here we go. Okay, sweet. So just right now we can see the polynomial fit like was good when the limit was between 0 and 1. Like when the limit between 0 and 1, everything is aligned, the circles is matches in like 1, 2, 3, 4, 5 in 5 spots. But when we are going from 1 to 2, it's obvious that it starts diverging when the limit expanded between like 1 and 2. So we can see that this area, it's where the divergence came from. So how can this be applicable? It always can be applicable like for your own data to see how your data matches until a specific point, and after this point it's gonna like diverge. So it's very helpful to know this, and it's very helpful like to represent this by figures. Like as you guys can see, we cannot like see this without actually plotting, or the figures are gonna be just numbers. So you will never understand the numbers until you're doing this with plot. And why we are doing this in general? Because like think about if you do have this data as a numbers, you will never, even if you are the best person with numbers, you will never have the correlation, or like you will never get that there is a diversion out from 1 to 2 until like you have the figure in front of you. Okay, so far so good. Now let's try like fitting, Polyfit, and Polyval, but now to an error function. So we are trying now to see, or to try with the error function. That's beautiful reinforcement. And as I said, like we are trying different features of Polyfit and Polyval, but it's the same sequence. So you guys will get used for the sequence over and over again. So I like this. It's kind of like practicing. Like we are learning a new thing, and the same thing, we are just add a small stuff, but practicing along the way. So I like that. Okay, same thing I'm gonna do now. I'm gonna clear all because I wanna have the same sequence, but like right now I wanna like do X, and then like I'm gonna do like line space and stuff, but there is X here, so overwriting error will happen. So in order to avoid that, I will do clear all. Now my workspace is empty, so I can write whatever I want in this section. So X will be equal 0, 0.1, 2.5 transpose. So I'm telling MATLAB that the x-axis will be start at 0, increase by step value like you're gonna increase by 0.1 the interval, and I'm gonna end at 2.5. So start at 0, end at 2.5, between 0 and 2.5 you're gonna increase by 0.1. What's this dash? This transpose. So we explained transpose before. Simply just to change the row vector to column vector. So right now, if we saw X, it would be column instead of rows. So if we played X, we have X all in the form of columns. If we remove this, it's gonna be now in the form of rows. So this is what transpose do. It just this comma over here. And we got, again, it's now column vector. So this my X, Y will be equal ERF. error function. We said like we need to fitting Polyfit with Polyval to an error function. So the error functions came like from error ERF. Okay, so ERF, and we are testing this with X. So ERF is responsible for finding an error if it does exist at each element of X. So it's just like it's acting as an inspector, which is inspecting the X variable to see if there is any error or not. Okay, so right now let's create the B, which is Polyfit X, Y, and this time the degree of polynomial, let's make it like 6 degrees. So same sequence, X and Y, right? 6 polynomial degree, so we do expect to see 7 values. So right now, if I press run, 1, 2, 3, 4, 5, 6, 7, because it's 6 polynomial degree. Okay, time for the browser, and usually to check how good the fit are, usually we have to use Polyval to see the accuracy. That's why there are browsers. So let's create now f right away equal Polyval, and here like polynomial evaluation. So that's why like it's evaluation for the Polyfit. And as I said, P, but this time we're not creating a new axis for Polyval, but because this inspector for the error, we are trying to find the error function, right? So we're gonna use the axis of Polyfit. So it's kind of like Polyfit is just asking Polyval to have a feedback whether it does have an error or not. This is how we're gonna like do this feature, or like how to find the error function. So yeah, now it's very noticeable that we didn't create a new axis, and this because we are trying to see if there is any error or not. So before actually start plotting, let's create a table with all of them first to see the actual values in front of us. Okay, so let's create a variable t and then equal table. This is very good review for how to create a table. So x, y. So the table function doesn't care. I can just keep going over and over and over. F. So y minus f. This y minus f. And as I said before, like if you can see this blue color, this means you are on the right path, because this means like it matches with another variable in your code, so you're good. But if it doesn't have this blue line, then you have to figure out whether you run this f before or not, because like MATLAB now can read f and y and x, but if there is the blue color doesn't exist, then you cannot, then MATLAB cannot read it. And now I'm gonna like give them names by function of variable names. And variable names, as I said before, anything related to string or text, it's always helpful to use those curly brackets. Okay, right now, xy, fit, and the fit error. So x and y, f, this is a polynomial fit, and this is the error. So we are trying to see if there is any error here, and we're gonna subtract this with the Polyval. So this will never happen without the help of Polyval, that's why. So now I'm representing here the x and y with a fit combined with a fit error, which representing it by y minus f, as I said. So let's run the table. Here we go. So I have x, I have y, I have the fit and the fit error. So we can see the fit error is like variation between like negative and positive values. So in the table we can see the fit value and the error, whether positive or negative. It's super helpful for calibration or adjusting like different instruments, like if you have tools. for like calibration, like the error is just negative 0.0, it might be negligible. But if you have like, if you are trying to adjusting something, it's just like adjusting by this value. This is the fit error, or this is the function of the fit error in general. Okay, so let's now create the second browser, which will be x1 equal, so almost same sequence, 0, 0.1, and 5. Here it was 2.5, now it's 5. But without any transpose. And now y1 will be ERF, error function, but for x1. So here we can realize for the third time, because this is the third like function we discovered today, like y1 or x1, x and x1, or y and y1 is have to be almost within the same limits to see any diversion within those limits. Like if you need to search for polyfitting in specific values, make sure that the limits in both x1 and y1 are almost the same or matches. Like Polyfit and Polyval are brothers, so they must have like similar characteristics. Okay, so now like this f1, this y1, so f1 will be Polyval. The browser need what? The browser needs a b, which is already here in my value, and then comma, the axis of the browser, which is x1. And as I said, if I press run, it's gonna be just numbers, so let's create figure 3. So figure 3, let's create the first plot, which is same thing, x, y. Let's make this in a form of circles. So this is the plot where we're gonna measure the polyfit with other points, and then hold on, and then another plot, x1, y1, line style will be this one. This will represent the polynomial line. Now, the third plot will be x1, but f1. Okay, the color would be just red. And the red where the polyfit actually diverge from the line. And I wanna also like create the axis or my own axis. So axis 0 to 5, 0 to 2. Okay, so just fast and easy to create your own axis in this way, because like 0 and 5, the first two, gonna be the limits or the x-axis limits, and the last two, 0 and 2, will be y-axis limits. And finally, hold off. Okay, let's run this. Now I can see where is like the fitting for the polynomial fitting and where it does diverge. So the red line, the line that I did specify here, this is how like it start diverging, and I can see where it when it start diverges, like which is 2.5 all over 4, and then it's gonna start increasing. But all of this perfect matching between 0 and 2.5. course, feel free to add legends, feel free to add title, X and Y axis, all this stuff. But the reason here today I'm very focused in Polyfit and Polyval. I don't want to take your guys' time for things like just be creative to do or to edit whatever you want, because we explained this several times. But today I just want to make sure that you guys are 100% familiar, 100% very comfortable with anything related to Polyval or Polyfit, and also like we try different features like the error and all the stuff. So today I'm gonna take something, it's really like I'm not making this video really long, but at the same time it's just like gonna be very quick, because I'm gonna represent something new, which is Polyvalm. Polyvalm is the same concept, same everything, it just in matrix. So it's matrix polynomial evaluation. So why we care about this? It just does evaluate a polynomial at a set of like scalar and vector points, but this time with a matrix input. So we need matrix. Matrix like bunch of rows, bunch of columns, create matrix. So, and this Polyvalm, like here I create like the fitting was along some points, okay, some like scattered data, but here it need to be a matrix. And I also can see the poly fitting in a matrix. That's why it's called like poly, like it's val, it's almost val but with a matrix, because it's almost same concept. So let's see how this will go. So I'm gonna create x this Pascal matrix. So of course like it's a matrix, that's why I choose this function, but Pascal simply means I want like 4 by 4 rows with 4 column. And Pascal is just a symmetric position, like it's definite matrix with integer entries, and it's taken from Pascal triangle. It's very mathematical based, I don't want to go in depth, but you guys can do more research to understand it deeply with complex calculations. But right now it's gonna give me the Pascal like matrix, like if I press run, 4 by 4 rows by 4 column. Basically it's all Pascal. So now we have a matrix ready for us from like using Pascal. And now let's create the P, which is poly now let's just create poly x. So polynomial in general used when you have a specified roots, but this in our code now we are replacing polyfit. So we're gonna use this P to be browser, but for Polyvalm instead of Polyval. And it's almost the same as I said, like Polyvalm and valid, just Polyvalm can do with matrix instead of points. Okay, so now y will be equal Polyvalm B is a polyfit that I did, and x, which is the axis. A good point, I have to clear all the workspace. Why? For overwriting error, to avoid overwriting error. So we can see, if we press run, we can see all the results here is very like almost close to 0, because this example of Cayley-Hamilton theorem, which is a math theory, simply says that a matrix could satisfy their own characteristics equation. So Polyvalm is not necessarily need a graphical representation, as all of you guys can see like now the function. It just you are checking the matrix if it's near 0 or not. If it's near 0, then we are on the right way. If not, then like it doesn't apply the Cayley-Hamilton theorem. Okay, so yeah, as I said, is not necessarily need now graphical representation, because this Polyvalm, which is matrix, but it it might like very helpful if you have like tables, maybe Excel, any calculation you need to do. It always like would be super helpful to use like Polyvalm along the way. So now we reach the time of our mini assignment. I wanna like save your guys' time today, so I'm gonna attach a word in the description in the video that has all the mini assignment. So please make sure you do the mini assignment. Now we have reached to the end of our episode. Make sure that you did right and tried everything by your own self. Feel free to do the mini assignment, leave comments for any questions. Make sure that you tried every section and like try the variation of things, because you might have like spelling error, you might forget something, you might like don't understand a lot of stuff, like you might struggle actually writing the code like as you go, because like a capital instead of small, all the coding stuff, because as always, programming about practice, and practice makes permanent. Thank you all, and see you all next episode.